Hi, and welcome to this section. Now, we've already covered Mongoose OS using JavaScript, and I'll give you an example with that using C code as well. For this section, I want to talk about Zerynth. This is a embedded operating system that allows you to program in Python, which is very cool. Now, it's not full-blown Python. You're not going to have access to every library like SciPy, NumPy, Pandas, all those cool data science ones. You get to constrain methods that you can actually access, but nevertheless, it includes a lot of cool functionality, including specific Wi-Fi IoT type instructions. So it makes it really interesting to use and helpful, and you'll see it covers a variety of devices, which we'll go over in a second. So if I go to Zerynth over here, I've already put in my ESP32DevKitC board, but if it doesn't recognize it, it'll let you disambiguate it. But you can also look at all the devices here. If I say choose a virtual device, so I want to actually program the code without uploading it to the board because I may not own the hardware yet, I can still go ahead and program by picking a virtual device. And you can see all these different devices that are handled, which is pretty cool. Okay, my ESP32 is already registered, but we'll just create a second virtual machine on this so I can walk you through as if it wasn't provisioned. So I'll just go ahead and create a new one. And we're going to go for a standard VM. You got the option of this photo-enabled VM, and you can read that in the documentation that I provided, but that's a new feature I won't get into. So you can see it's creating a new virtual machine for that. Cool. And now that we created it, let's go ahead and virtualize it. And that's all correct, so go ahead. And what this is going to do at this point is use the ESP tool script. That's a script provided by Espressif, the manufacturer of the chip. It's not a script specific to Zerynth, but once that firmware is on there, it can be virtualized in the machine. And then in the next lecture, we can go ahead and link it up with our AWS IoT account, and you can see it's running to Flash right now. All right, it's finally done doing that. I don't think there's anything left to do. I think we're already finished. Just to give us a final result. Yeah, we're already done. So let's move on to the next lecture. In the next lecture, we'll be doing the control publish period program, and then we'll be altering that program for our own push button handler script to deliver our JSON package. So let's move on to the next lecture with that.
AWS in this part of the lecture using a sample program that Zerynth is going to provide specifically for AWS IoT. Now, after we finish this, we're going to alter this program in the last part and get it ready to go for what we specifically want to do, delivering our JSON package. So the first thing we want to do is after opening Zerynth is opening a sample project. We don't want to reinvent the wheel. So we're going to go over here to the projects folder, and I'm going to go to this one for AWS. Makes sense, right? And it's called, there's only one available, it's controlled publish period. We're going to change the period to, again, a button controller. But let's go ahead and clone this, and then it'll ask us which directory to clone it into, and then we'll change it. So I'm just going to call it CPP, and it's going to put it into that directory and create it. So that's kind of nice. It handles that for us. Okay, so this is what we have so far. But we need to add our certificates into this folder, and we also need to configure this little JSON packet with the details to link to our AWS IoT account. So let's go to AWS IoT and start pounding these things out. And the first thing we should probably get is our endpoint, because we already know where that is from using Mongoose. So we'll go over here to AWS IoT. And from AWS IoT, we can go over to settings and grab our endpoint right here. And this is our endpoint, whether we want to use what we're using in Mongoose and Zerynth, which is this MQTT broker, but it'll also work with REST endpoints as well, so that's useful to know. All right, so let's go ahead and put that right over here. No, we don't want it there. We want it over here in our endpoint. There it is. So it's going to have our MQTT, the server-side broker endpoint, as well as the rest of our region and what we're already used to using. Now let's go over to Amazon AWS and create a policy and provision it correctly with the kind of permissions we want it to use. So again, when we used Mongoose OS, it did this for us, but we're going to have to do this manually, but luckily it's not very difficult. So let's go over here to Secure and Policies. Now I already have a previous Zerynth policy, but let's go ahead and create a new one. But before we create a new one, let's look at our old Mongoose policy, because this will give us a really good template. Zerynth recommends you do a longer policy that I've looked at, but this policy actually is better because it just includes everything. With any of these policies or IAMs you'll see as we go through the course, I always like to have a superset and include more that's needed. And then when I go into production, I can start eliminating resources and actions as needed for security. But I would rather start with an over-inclusive policy make sure everything works, and then start reducing permissions and actions. So I'm just going to copy this, and if you haven't done Mongoose yet, don't worry about it. And now I'll create a new policy for Zerynth. So I'll say create, and we'll just call this Z2. Doesn't really matter. You can make it as long or short. Now you can fill these out manually. It kind of gives you a little assistance to add IoT resources, effects, whatever. I just go to advanced mode and see it has an empty template here. So we're just going to paste in the Mongoose policy, and I'll provide this policy in the resources, but the main thing you have to know, it just allows everything that's included in that IoT dashboard. Now this will give us action too. So let's go ahead and create this Z2 policy, and there it is, our brand new policy. Okay, now that we've created our inclusive policy, let's go back to Zerynth and stick that in our thing.json configuration. So our policy is now known, it's just Z2, and again, you can call yours whatever you want. So we're missing three things still. We don't have our certificate ARN, we don't have our client-side MQTT ID, we do have our server-side endpoint over here, but we're also missing our thing name. So we're going to take care of all three of these at once. So how are we going to do that? And again, Mongoose handles this quite differently, is go to your command prompt. And from your command prompt, we're going to type in a Zerynth specific string of commands. If you have your path set correctly from the installation instructions, you'll have it access pretty much from any directory you want. But that's going to be a little bit different if you're using Linux or using Mac. So we're going to type in a specific command that's going to allocate our policies and provision our things and connect our certificates. So let's go ahead and do that. So how this is going to look is ZTC, that's the Zerynth specific command, AWS, similar to the CLI, add things, and we're going to go from wherever our project directory is. From here, my project directory is just one file over, but you'll handle that differently depending on where you placed it. And remember, we called my project CPP, Control Publish Push, or whatever it was called. I just shortened it because planning on this step, I didn't want to type in a really long name. I have pretty poor typing skills. Thing base name, and I'm going to tell you why that's important in a second. The reason we want to have a base name and declare the number of things is because we may be provisioning 50 devices. Again, if we were doing an industrial application in real life production, we may have 50 embedded devices we need all provision at once. So this tool allows us to do that, and that's just going to create a single thing when I say things number. And here's where I can put 50, or I could put 1, or I can put 200. How many I want to provision, and then give me a number up to as many as I'm provisioning. Go ahead and enter this, and if everything's entered correctly, it's going to attach my certificate. So it's creating zthing0. That's because I only have one. If I had two, I get zthing0 and zthing1 all done for me. When we hit that AWS IoT provision button, this is doing the same thing, but from the command prompt. Okay, let's go make sure this works. We can see we still need these three fields filled out, but we see we have our certificate in here and our private key in here. So we know they're there. So you just have to close this out and then come back in here, and now it's in here. It doesn't dynamically refresh. But now we have those last things we needed. We needed our cert ARN. That's in here now. We needed our MQTT device. Our thing name is the same, thing0. So we're all in here now and we're good to go. So everything's correct. So the last thing we need to do is go back to AWS and check indeed that when we go to our AWS IoT things, our new thing is in there. And if you open this up and look at it, you can see that this matches what's over in our provisioning over in Zerynth over here. Those are correct. So everything's matched and it's created this thing now in AWS IoT from that command prompt. So the last thing we're going to do is go over to our main Python program. We're going to change it for what we want to do with our push button handler rather than dealing with this time interval and add in our correct JSON packet. So let's go ahead and do that in the next lecture. Welcome back to the Zerynth portion of the lecture, and we were speaking about this demo code. So before we go into the demo code, there's a couple things I wanted to talk about that are really relevant to IoT and AWS IoT specifically. So in the last lecture, we configured our JSON packet with our policy and certificate definitions in MQTT server-side broker, so it know where to found it to connect to AWS IoT. This lecture, we pulled up the sample program now that we have our certificates, and we're going to make some changes before we want to run it to make it look like our Mongoose program. So for the rest of the course, when we go over these Amazon services, we're getting a consistent JSON package that we can put in the database and move to S3 and do analysis and graphing. So we're not dealing with a bunch of different packages from a bunch of different IDs and programs. But there's two things I want to talk about. And if you're going for a job in cloud IoT, there are two things you should definitely know about. One is QoS, but probably the more important topic is shadow services. Now, Zerynth in its constrained Python set, again, this isn't a full version of Python. Eventually, you will have a full version of Python that you can put on an MCU. But compared to JavaScript running on V8, it's a little slow and it actually compiles to a ton more code. So Python's going to be a lot more constrained than JavaScript because of that, and certainly a lot more than a compiled C program. But one thing that Zerynth did nicely is they included functions and class members for shadow services and shadow callbacks. So when this connects to AWT, in the shadows section, we'll be able to alter it from the cloud side back to the device side. And you're going to see where that's important. Because if we want to send device updates, we can now do that through the cloud through MQTT with these shadow services. And this isn't only true with AWS IoT, it's also true with Amazon Azure, and I think Google IoT has shadow services as well. They may call them something different, but they're basically the same thing. So where those shadow services are, if you go to AWS IoT and you go to the thing 0 we just created in the last lecture, and then we hit shadow. Now right now there's nothing there. Why? Because we haven't transpiled our program and then connected it with AWS. We have everything in place to do that, but it doesn't know anything about our code. So that's what we're going to do next, and then we're going to update this, and we're going to see how it's going to talk to Amazon AWS to be able to change from publishing a change in the cloud with the shadow service and receiving that in the device. Okay, so that's what the shadow service is, and we'll talk about the QoS, the quality of service. Okay, so what are the big changes that we need to make to this program? Well, a couple of them of the bigger changes are, again, you can see that this is on a timer, and just like with Mongoose, I don't want to publish this on a timer. It's just going to fill my box with messages, and I don't want to do that. So what I'm going to do is I'm going to change that just like we did with Mongoose and JavaScript. I'm going to change that to a button handler. That's number one. The second thing, which is going to be easier to do, is I wanted this as close to identical as it can get to that previous JSON package we sent out from Mongoose and JavaScript. So again, it's going to have the same JSON format. It almost looks identical, and that format is just this key value pair. So we're going to want a key value pair for what? Time, device ID, humidity, and temperature to send our sample data up. So we'll be making those changes as well. So only the couple things we have to do is add in our personal SSID and password, add in an additional library, and alter some minor code, which we'll do in the next lecture. But let's go ahead and run this so we can see the change in shadow service. And to do that, you need to compile it here and run it. But if your device isn't connected, and I don't know why it lost connection with my device, there it goes. If your device isn't connected, you actually can't compile or run it, which is kind of weird because normally you can compile it without a device. So I'm going to compile it in uplink, which will do the compilation and the uplink all at once to my device. There it goes. Okay, it says uplink done. That's how we know we're finished with. So let's go over to Amazon and check out our shadow services and see if they're active now that we connected with the program. So here we're in our device, our thing. Going over to shadow, yeah, now we're overall active. You can see that the shadow call from that function in Python, or the constrained Python set in Zerynth, has our shadow period of 1000. Now, if we wanted to change that to be updated for some other time, obviously we would just have to change this over to a time that we wanted. So it makes it a really efficient, useful service. And again, if you have a technical job interview, that's a good question to know. But what do we need to subscribe to on the cloud side to be able to get our published data? There's our topic right there. So we're going to publish this from the device dev/sample and receive that on the Amazon cloud. So let's go back to the cloud here, and we'll go to our test section, and I want to subscribe to dev sample. Great, I'm subscribed. And yeah, I haven't changed it to the button handler, and it's just giving us, if you look at the code, it's just giving us a random sample between 1 and 10. And the last thing I want to talk about is that QoS I briefly mentioned. Now, usually a QoS of 0 to 2. Right now, I think Amazon's only handling 0 to 1. Which is why it's only listed 0 to 1, so obviously that's true. So a QoS of 0 means one time at the most. QoS of 1 means at least one time, and then you got a QoS of 2. I don't think it goes any higher than that. Again, you can check that out in the MQTT article from the Hive that I linked in the resource section under that MQTT section. Okay, so what we want to do next, now that we're online with the samples code and we kind of see how it works, we want to get our own JSON package, and we want to change this timed loop into a button handler. So when we push that flash button at button 0, we can get our JSON package. So let's do that in the next lecture. Okay, welcome back to the next part of the lecture here. All right, we have our sample program, which is made by default, control publish period, and we're going to change it so we get a push button action, so we're not dealing with that timer interval, sending those incessant messages over and over to Amazon AWS IoT. So for this, we just need to change the code and add a few things to make this work completely with what we want to do. The first thing I want to do is bring in an additional library, and as you're going to see, this library is going to help us with our timer function or our clock. So I'm just going to import timers. And again, that's a Python constrained library that Zerynth provides that gives us some nice timer functions. The next thing I want to do is define a pin as button pin, and that's going to be on button 0. And remember, with our ESP32, button 0, as it's defined in the hardware abstraction with Zerynth and Mongoose as well, is tied to that flash button. So that makes it really convenient for us. Now, if you've ever messed around with Arduino before, this next line I just pasted in here should look really familiar to you as well. This just defines that button pin we just defined to button 0 on the flash as an input. So this is similar to what it would look like in Arduino. Now, the last thing we need to do to change our code is we don't want this function, while true, continually sending this messages every publish period. And the publish period here is defined as 1 second or 1,000 milliseconds. We could change that to a longer period, but I still want more control. So to get that asynchronous push button control, I'm going to make it a push button handler just like we did with Mongoose. So let me go grab that code. I'll paste it in here. Okay, I pasted that in there, and that's what our new code's going to look like. So basically what I'm doing here at the end of the program, I'm calling, with Python you have to define it, and in the definition is the function. So this looks a little weird if you're used to using C or JavaScript, where you can put the call in before you put the function, but since in Python the definition is the function, how it's designed here, we have to put the call in after that. So anyways, we're calling this button pin, again, that's button 0 pressed. So while it's pressed, I should get rid of this while it's true and while it's pressed. When we pressed it, what's going to happen? We're going to publish random sample, and it's going to print our new JSON packet. Now, if you look at the old example I did before I erased it, it just had that A sample and a random number between 1 and 10. So let's walk through what we're doing with this JSON packet. Okay, so I'm leaving it the same name. We're publishing that to the topic dev sample. But the first thing I'm going to do is publish the device ID again, so it matches up with the JSON package from Mongoose OS and the JSON package we want to use pretty much throughout the rest of the course. So if you look up here, it has some predefined functionality for identifying our thing. Now, unlike Mongoose, we named our thing here. Remember, we named it Z2 in AWS IoT, but we can call it whatever we want, and this will give us that name. So this is going to say Z2, but you probably named yours something different, which is fine. Secondly, and here's why I imported the timers library, I can't get that nice UTC time or standardized time I could in Mongoose. It's just not defined in Zerynth's Python constrained library, but I will get some kind of a time. I'm going to start this timer when we open the program. So the main thing that it's doing, which is what we want anyways, is we want to be able to separate our sample data readings by time, which although we are not using UTC time like we were in the previous example in JavaScript, we're at least getting some differentiation in time. The last two things are going to look real familiar to you because it's almost the exact same thing. I'm just putting the humidity as a random variable between 0 and 50, and the temperature as a random variable between 1 and 100. So let's go ahead and upload and run this program to our ESP32DevKitC or whatever device you're working that's compatible, and then we'll go look at our Amazon result. And I got to connect it again before I can run it, so let's go ahead and run that. All right, it says uplink done. That's how we know we're finished. So let's go back over to Amazon over here and put on our test console. Good, we got that connection we're looking for. Now we'll have the topic as dev sample. Now remember before, every 5 seconds or every second, we were getting that coded uploaded. We don't have that here, which is great. We don't want that. We want to asynchronously push that flash button. So let's push that flash button and hope we get our JSON packet correctly. And there we go. Again, zthing 0, it's not Z2, that's how we defined our policy. Zthing 0 is how we defined this. All right, I clicked it a few more times as well to get some more sensor data packages. Now I will mention, unlike the other example where we use that button handler from Mongoose, and we have that shadow service in there, you can't just click the button 5 times really quick. You have to kind of wait 5 seconds or 6 seconds between button clicking intervals. Just be aware of that fact, and let's move on to the next lecture.